So the next question is one that comes from Mabutla V. Matsecha. Thank you very much, Matsecha, for sending this awesome question that looks very intimidating. The love letter reads as follows. It says in the diagram below, two circles touch at A. Okay, so they touch at point A. S and L are the centers of the circles. So clearly, I think we can all see that S will be the center of the small circle, and then L will be the center of the bigger circle. Okay, all right. Now, D is a point on the small circle, right? And C is a point on the large circle. ADC is a straight line, okay? M is a point on LB. There's M, which is a point on LB, such that MN, so your MN there will be parallel to LC. Okay, good news there. So this is simply parallel to this. Immediately my brain tells me that the proportionality theorem is likely to play a role in this particular question. Question 1 says to us we need to prove that DL is parallel to CB. Okay, we must prove that this line DL is parallel to that line CB. Now, what do we see here? Well, we should know that if there is a center in a circle, you are likely to have a diameter. So I'm going to use this theorem that says if you've got a center in a circle and then you've got a diameter, an angle that is going to be subtended by a diameter will always be 90 degrees. That is what I'm going to use. So I'm going to first of all argue that this angle here is 90. That's where I'm beginning my argument, right? I'm going to argue and say ADL, angle ADL is 90 degrees. Why am I saying that? Well, this is an angle subtended by a diameter, right? Diameter, which diameter is that? That's the diameter AL, okay? But even the other one, angle ACB, the one at the bottom here, is also subtended by the diameter AB. So ACB will also be 90 degrees. Why? For the same reason. It's an angle that is subtended by the bigger diameter because it is in the big circle, right? Therefore, ADL equals to ACB, okay? Therefore, we can then conclude that those two lines DL is simply parallel to the second line CB, and the reason will simply be because of the fact that alternate angles, a pair of corresponding, not alternate. I'm using the F theorem from Fun. Remember Fun? F, U, and N, corresponding, coincident, alternate. So I'm simply using this idea because they will make a nice, beautiful letter F if you look at an upside down letter F. So since these angles are simply equal, it's a pair of corresponding angles, not alternate. Pair of corresponding angles are equal, therefore those are simply going to have to be parallel to each other. Right, very, very powerful indeed. So if you want to prove two lines are parallel, you can prove any of these. Prove corresponding angles are equal, prove coincident angles add up to 180, prove alternate angles are equal, then you can claim that the lines that are making those angles are simply parallel to each other. Right. Let's go on to the next question. The next one says to us, we need to prove that 2 times SD is simply equals to LC. Right. 2 times SD equals to LC. Now look at this. Very, very important for you to keep your grade 10 knowledge in this particular question. Now, if you look at this question, I'm going to just remove what we have so far so that you can focus on where we are. We want you to show that this, right, double of that will just be equal to LC. Now, if you focus on this triangle, again, I see the proportionality theorem coming in picture here. Why? Well, because this is the center, so that means this is the radius and this is the radius. Secondly, we know that this is perpendicular to that, which means from our knowledge, right, from our knowledge of what we did in grade 11, we know that the line from the center that is perpendicular to a chord of the big circle will bisect the chord. That means this AD will just be simply equal to 2 times of that particular line that you're looking at right now, which is DC. So since AD equals to DB and AS equals to L, since this is point L, then the proportionality, not the proportionality, but the midpoint theorem holds, because like I said, those 4 elements that I spoke to you about, the 4 elements that I told you about, if any 2 holds, then we can then claim the other 2. It's all the question that comes from, the concept that comes from grade 10. So if you have these 2 that are true, then you can use this as a conclusion in order to solve a problem, right? So that's simply what I'm going to use in this case. How do I build my argument? Well, I'm going to start first of all by saying AS equals to ASL because S is the center and those are radii. So AS is equals to SL. The reason is those are simply radii. That's the first thing. Secondly, I want to argue that AD equals to DC. So AD is equals to DC. Why? Well, the reason is because a perpendicular from center bisects chord. Perpendicular from center bisects your chord. It's a theorem that you guys learned, that if you've got this and you've got that, and this is perpendicular, then that will be bisected into 2 equal pieces, right? Very powerful. Now that I've done that, then I can then conclude that it means that DS is parallel to LC. Therefore, DS is parallel to LC, and I can also add and say that 2 times DS is equal to LC, since DS will be half of LC. Why? Because of the midpoint theorem. Midpoint theorem. So please be careful of these grade 10 things that they might like to put in these kinds of questions, and they may give you problems. So make sure that you are also aware of what is happening as far as this midpoint theorem is concerned, because it does creep in here or there sometimes. So please be careful of that. Right. Question C says to us we need to determine the value of SL divided by AB. All right. SL divided by AB. Where is SL? Where is AB? Now SL is, let me remove all that we have so far, but never forget what you've just worked out up to so far. If you've got color pens, it helps because you can then keep everything in your diagram without any problems. So I just want to keep cleaning the diagram so that you can see where my analysis is going. So we want you to find the ratio of the side SL. That's what we want. We want to find the ratio of this SL, right, divided by AB. AB is everything that you see there. Okay. Now, what I normally do in these kinds of setups is I like to introduce variables. If you introduce a variable, particularly if you're dealing with SLs and ABs and PQs or angle B1 and angle B3 and angle B7s, and I want you to prove something is equal to something or find some ratios, I always introduce a variable. I just say to the examiner, please allow me to call something X. And then I just work with X. Find who else is X, who else is equal to X. When you do that, you'll notice that the question becomes easier because it's like you're forcing it to be a numerical problem. If it was numbers here, it's easy for you to work with the question. But since you're dealing with variables and lengths of sides named using letters, it becomes a bit of a challenge. So introduce a variable and play around with that variable. You'll see the question becomes very easier. Let me show you what I'm talking about. So I'm going to the small circle. Let's focus on the small circle with the center SL. So I'm going to ask the examiner to allow me to call SL X. So if this thing is X, who else is going to be X? Well, SL is basically the same distance as SD. That makes SD to also be X. That makes AS to also be X because all those are radii. Now, since L is the center of the big circle, from A all the way to L, I'm looking at 2x. That means this will also be 2x in total. I don't know what's going on with M, but I just know that from L all the way to B, we are looking at another radius of the big circle. That makes the entire thing to be equal to 2x. What does that mean about the whole of AB? You've got 2x, x and x, so it therefore makes it to be equal to 4x. You see, it becomes way easier for you to analyze the problem if you introduce some random variable. Don't introduce too many variables though. Put x. If you see a need, put y. Once you feel like you need to introduce a third variable, you must know that now that you're going too far, right? Put an x there for SL. Find out who else is equal to x. SA will be x, SD will be x because all those are radii. And then LB will become 2x because it's the radius of the big circle. And then the whole thing of AB will then definitely be equal to 4x. Therefore, the ratio you're looking for of SL over AB is just x divided by 4x, which just makes it to be equal to 1/4. And that will be the solution to that particular ratio that you're interested in. All right, last question says to us that if AB, right, AB, if AB is equal to 30 units, AB equals to 30 units. Allow me to remove everything now so that we can see where the analysis is going. So we are told that AB is equals to 30. If AB is equals to 30, what do we know? Well, if the whole thing here is simply 30 centimeters, we've got a numerical value now. They want us to find Bn divided by Nc. They want Bn divided by Nc. Where's Bn? Bn is this. Where's Nc? Nc is this. What does it look like? It looks like we are here, right? It looks like we are here, okay? We're definitely here. Okay, cool. Right, now we know the ratio of this side to this one. Remember not to write them as values. If it's 7 to 9 for Bn and Nc, I'll call this 7 times something. I'll call this one 9 times something. Okay? We know that 7 and 9 from the given information. They want you to find the length of Lm. So they want this small piece here. Okay? Now, if you want that small piece here, I might be interested in knowing how long is the whole of Lb. Right? How long is Lb? Now, look at that. We've got 30 as the diameter of the big circle. That means from here all the way to there, we'll have 15, since that's the radius of the circle. So I'm going to have 15 centimeters there. And then obviously from here going there is another 15 centimeters. 15 for the other radius, 15 for the other radius. So I'm just going to focus on that triangle that you're looking at right now. What am I going to say? Well, I'm going to say I'm sitting with 7K and 9K. I'm looking for Lm. I've got 15. Very simple stuff, right? We've got this. Okay, we've got 7K here, we've got 9K here, and the whole thing here is 15 centimeters. They're looking for this. Okay, that's all that they're looking for here. All right, now let's see what will happen here. Okay, so we just want this. Let's just call it X if you like. So I'm going to go long over short. So how am I going to do my proportionality? I'll say X divided by 15. I'm going the short side over the long side, right? That will be equal to, if I go short over long, it should be equal to short over long as well, right? So X over 15 centimeters will be equal to 9K over 7 plus 9 is just simply going to become 16K, right? That's the length of the long side. Where am I getting this from? This is from the proportionality theorem, since we've got parallel lines, right? Parallel lines. I forgot the names of these lines. You obviously need to write what the names of the lines are. And obviously in our question, it was MN, right? MN is parallel to LC. So this is parallel to that, right? Okay, cool. So now we want to find what the value of this is going to be. So simple cross multiplication, cancellation of the k's here goes away. You cross multiply, you end up with a value that says X is 9 multiplied by 15 centimeters divided by 16, okay, which you can then call your calculator to try and figure out, because the calculator is an instrument. Use it. It's not a monument. Use it. 9 times 15 divided by 16, and we end up with something awesome. The answer becomes 8 and 7 over 16, which is 8.4375. 8.4375, which obviously to 2 decimal places has to definitely be equal to 8.43 centimeters. If you have to round off the answer to 2 decimal places, it is 8.43. So if I have to round off to 2 decimal places, the boundary is here. So that 7 will definitely change my 3 from a 3 to a 4. So the actual answer is supposed to be 8.44 centimeters. Also put it as a ratio if you ever wanted to do that. So it's a beautiful answer that you're getting. I hope you understand how you had to work with these kinds of questions that have got all these intimidating lines. Just keep writing what you have from the love letter. After finding something, update your diagram. And once you keep on working on that, every time you find an answer, keep updating your diagram. If you meet unknown letters that they want you to find, and you don't know how to do that because it looks too chaotic, introduce a variable. You'll always be able to get to the answer without much of a challenge.